So hello and welcome friends to our channel Intro Mech, and here we discuss about basic mechanical engineering concepts. So guys, you know that we have started a new series, and the main purpose of this series is to make you guys aware that how you can simply utilize the SolidWorks and its simulation tool to understand some basic concepts which you have studied in say engineering, and what are the application of those concepts, like how those concepts are applied in the industry. So my main focus is how these things are practically applied in the industry and how you can cross verify these things with the help of simple simulation. So if you want more content like this, please subscribe to my channel and don't forget to hit the bell icon. So without wasting time, let's get started. So let's first see what is stress concentration. Now we all have learned this thing in our engineering, that it is a localized stress which is considerably higher than the average stress which is getting induced in the body, and it is basically because of the abrupt changes in the geometry or say localized loading. So it's also called as stress risers or um, stress raisers because they induces more stress in the bodies, you can say localized stress in the body. So let's see. Now here you could see a simple plate which is under tensile loading. We have applied a force of P, and now let's cut the plate here at this section, and we can see the stress distribution which is uniform, and we have got the sigma max. Now if the sigma max say greater than the yield strength of the plate, there the deformation will start, and as soon as the stress gets more than the ultimate strength of the body, it will fail. Now let's see what happens if say I drill a hole in the plate. Right, now this is the case. Here we are using the same plate, but what we have done, we have drilled a hole here and we are taking the section here. Now here you could see the stress distribution. Now the stress has changed, and here we have an average stress value, and then we have the maximum stress value. Now here you could see this maximum stress value is definitely greater than this maximum stress value. What it indicates, that this part will definitely get filled earlier than this part. The maximum stress is getting induced, so there might be chances the crack will develop and it will propagate and the plate will get failed. Right, now this is nothing but an abrupt change in the cross section. You could see this is the abrupt change in the cross section, and because of which the stress is getting concentrated. Now what is another example of abrupt change which is commonly used? Now you can consider this is a stepped shaft. Right, so you could see the flow lines in the first case, like you could see the crowded flow lines over here because of the sudden change in the cross section. And if you compare this with this part, we have fillets to this part, and because of which the flow lines now got smoother, so the stress concentration will be lesser and the part can survive, can take more stress. So this thing is actually practically utilized in the industry. So let's check out how. Now this is the plate, simple plate which we have seen, right, and it has some breadth and width and thickness. So let's check out the simulation wizard over here. What we have done, we have fixed the plate at one point and we have applied a tensile load. Right, we have fixed this face and we have applied a force of say 1000 Newton at this face. So we are pulling the plate, right, and we will check the stress value which is getting induced in the body. Right, so let's check out the stress how much stress we are getting here? It is 1.88 into 10 raised to 6, which is lower than the yield strength. But you could see the maximum stress which is coming in the body is like 1.88 into 10 raised to 6, and the displacement we are getting is like 7.42 into 10 raised to minus 4, right? So this is our simple plate. Now let's check out another plate over here. Now we have drilled a simple hole in the plate. Now check out what happens. We are having the same conditions. We have fixed this face, we have applied a force of 1000 Newton over here, and we have run the simulation. Now let's check out the values over here. The stress value, you could see it is 3.78 into 10 raised to 6, and you can see now the maximum stress has got concentrated at the whole section. You can see the red spot at the whole section over here, and the stress is like 3.78 into 10 raised to 6, and you can see the bending. You can take this section, it is not operating, but you could see the maximum stress which is indicated by red, right? Now here you could see the stress which is 1.88 into 10 raised to 6, right? So the stress value has increased. You could see that is 3.78, considerably it has increased. And also you could see the portion. So what will happen, the crack can generate at this section and it will propagate and the plate will get failed, right? So we have checked with the simulation that how this stress concentration affects. Now let's check out the practical example in the industry. We have, say, a stepped pin over here. You could see we have made it, let's say, with the turning, with the sharp cross section changes, right? You can see over here. Let's check out, let's do a simulation. We have fixed this face and we are pulling the other face over here with 1000 Newton force, right? And what we have here, we have got the stress value 1.62 into 10 raised to 7, right? We can see the stress which is getting concentrated at this section. Definitely it has a lesser cross section, so the stress value will be higher at this section and the part will most likely fail at this section, right? So the maximum stress is like 1.62 into 10 raised to 7, right? And the displacement is 2.23 into 10 raised to minus 3. So this is the part with sharp cross section change. Now what we are doing, we are having some smooth change in the cross section. We are having some fillet to the shaft, or here you can see the fillets in red, right? And if we see the cross section, you could see that there is a smooth change in the cross section, unlike the in previous section there was abrupt changes. Now same, we have fixed this end, we have applied a force of 1000 Newton over here, and what we have taken is alloy steel, same material as previous, and we will run the simulation. Now the simulation has completed. Let's check out the result over here. Let's check the stress value. It is like 1.52 into 10 raised to 7. So we can see that the stress has the maximum stress has reduced. Here you could see the stress is like 1.62 into 10 raised to 7, and here the stress is 1.52 into 10 raised to 7. So the displacement, you could see, has also got reduced slightly. In the previous case the displacement was 2.23, now it is 2. So there is slight change in the deflection also, and you can see the maximum stress value has also got reduced. So this is the practical application, you can say, why the most of the parts in the industry don't have the sharp cross section changes. We always give the smooth fillets. Then we have groove cut on the shafts. So these are the reasons why we do it while designing some parts. So my purpose of this video was to make you understand by why these things are done into the industry. So I hope you understood the things and you liked the session. So if you have any doubts, please do write into the comment section and we can discuss over there. Until then, stay home, stay happy. Thank you for the patient listening. Thank you.